Let's start the seminar. Okay. Yeah. Now for the first 10 to 20 minutes, we'll learn the basics of probability and we'll try some examples. After that, we can start practicing the questions on probability. Okay? Yes. What is probability? The chapter of probability includes the terms like experiments, outcomes, events, sample spaces, probability of an event, and some basic rules in probability. Okay. Any idea, guys, about experiments and outcomes? Just share your thoughts. What is experiment? What is outcomes? Probability includes all these terms. Guys, what is experiment? Outcomes? Possible of chances. Gautam, outcomes means result which you got. Yeah, from which we should get that outcome. Experiment is the event performed saying throwing dice. Okay, you're giving some examples, but you have some thoughts. That's good. Something might happen, Kishore. Probability. Okay. When we want to know some results, if we go for some practical one, then it is experiment. Fine. Suresh, you are almost correct. Correct. Okay, let's see some examples on this. First, let me tell you about the experiment. Okay? Yes, experiment is any activity from which results are obtained. It's any activity from which we will get some results. It's an activity. For example, determining the value of G using an oscillating pendulum. Value of gravitational force. It may change in for each and every places. So we will get many results through this experiment. Here the experiment is oscillating pendulum. We are going, if we oscillate the pendulum, will get different values of G. The values of G are results, and experiment is oscillating the pendulum. And determining literacy rates in 100 village of a district. It's also an example. Census and population studies of a country. It's an experiment. And popularity rating of public figures. Okay, this is also an experiment. Here we are doing rating of public figures. It's an experiment. Is it clear, guys? That's great. Okay. And random experiment is one in which the outcomes or results cannot be predicted with certainty. Okay. It's we can't predict the results exactly. We cannot predict it with certainty. We cannot tell the results exactly. Yeah, this is the outcome for this event. If the experiment is like that, then that experiment is called random experiment. Random experiment is one in which the outcomes or results cannot be predicted with certainty. We cannot predict it exactly. We cannot tell the results. For example, here flip a coin, can't predict the head. We don't know whether we'll get head or not. We have possible outcomes, head and tail, but we can't tell if you flip a coin, we'll get head. We are not sure. Okay, rolling a die, cannot predict the digit. You'll get 1, 2, you'll get 1 or 2 or 3, like that. Measuring height of the child on her 5th birthday, it may differ, it will differ. One child it's more than 2 feet, 3 feet, it depends. Okay, shall we move on? Is it clear about the random experiment, and random experiment? That's great. Basic outcomes and sample spaces of an experiment. Yes, basic outcome is one possible outcome of an experiment. Only one possible outcome. It's an example. If you conduct any experiment, if you have any one possible outcome, that outcome we can call it as basic outcome. Sample space is nothing but set of all possible outcome. Set of set of all possible outcomes of an experiment. Throwing a die will get throwing a die will get 6 possible outcome. 1, 2, 3, up to 6. Like that. Is it clear? Yes. Select 2 cities out of New York, Boston, Chicago, Los Angeles. It's an experiment selecting, we are going to select 2 cities out of these 4 cities. So outcomes are, total possible outcomes are New York, Boston, New York, Chicago, New York, Los Angeles, Boston, Chicago, Boston, Los Angeles, Chicago, Los Angeles, Los Angeles. These are the outcomes. So here the basic outcome is any one of the outcome. New York, Boston, we can say like that. And sample space contains all the possible outcome. Here we have 6 possible outcomes. Okay, is it clear? That's great. Events. Yeah, it's a favorable subset of the sample space of an experiment. It is a favorable subset of the sample space. If we conduct an experiment and if you have any favor, suppose throwing a die and getting 1 on his head, our favorable outcome is getting 1. So event is nothing but event of getting 1 while throwing it when we throw a die. Okay, event is a favorable subset of the sample space of the experiment. Favorable subset of the sample space. Fine. Example here is select 2 cities out of New York, Boston, Chicago, Los Angeles. Same example. Yes, are favorable. We can select anything. Okay. Probability. So we can conclude it as probability is nothing but a mathematical measurement of chance of occurrence. It's a chance of occurrence. Okay. Let's see the mathematical definition of probability. In words, it's a chance of occurrence on a particular experiment. Okay, probability of an event A is defined as the number of favorable outcome by total number of outcomes. Number of outcomes that are favorable of A, favorable of A to total number of all possible outcome of the experiment. Is it clear, guys? Shall we see some more concepts and examples? Do reply. That's great. Okay. Yeah. Probability of an event. Here we are considering E as the event. Chance that an event will occur. This chance should, probability should lie between, from 0 and 1. If we get the probability as 0, this implies that the event E will not occur. It's a null event. And if you get the probability of an event as 1, then the event will occur. Will definitely occur. It's an sure event. Okay? But probability values lies from 0 and 1. 0 to 1. There are possible chances between the two extremes. Okay? 0 and 1. Fine. Few more examples on probability. Probability that a file is downloaded successful from a website. It's a real life example. Probability that a flight will arrive on time. Probability that a student will score 170 in quants. Probability that your favorite team will win a tournament. Probability that this year exports is 25% higher than the last year. Real life example. Hope you understood the concept of probability. Shall we move on, guys? That's great. Okay, just give me your answer for this question. What is the probability that a card picked randomly from a deck of cards in an ace? Good work, Karthikeyan, Pratosh, Heetana, Yuvraj, check your calculator. What happened? Okay, Aishwarya, Vinod, Aditi, Jayesh. Yeah, most of you has given correct answer. Have given correct answer. Okay, that's fine. It's very simple. Out of 52 cards, we have 4 ace cards. Picking an ace card from the pack of 52 cards will give a probability 4 by 52, nothing but 1 by 13. Okay, Yuvraj, the answer is 4 by 52. Okay, because we have 4 ace cards and total cards are 52. 4 by 52. Fine. Good work, guys. Shall we move on? Yeah. Yes. Bob has observed that following while downloading files from the internet. For files whose size was less than 5 MB, the downloads were successful 18 out of 20 times. Okay. When the file size was greater than 5 MB, the downloads were successful 12 out of 20. Presently, he wishes to download a 4.7 MB file from the internet. What is the probability that the download will be successful? 5. If it is less than 5 MB, 18 out of 20. If it is greater than 5 MB, 12 out of 20. Presently, he wishes to download 4.7 MB. It's less than 5 MB. Yes, most of you has given correct answer. That's great. The answer is 18 by 20, 9 by 10. That's great, guys. Okay, let's see some more concept. Method to determine probability. Objective methods are equally likely approach, relative frequency approach. Let me tell about these things in detail. Okay, two methods, equally likely approach, relative frequency approach. Equally likely approach. If an experiment must result in n equally likely outcomes, then each possible outcome must have probability of occurrence of 1 by n. If it is results in n equally likely. Okay. For example, rolling a die. If we roll a die, we have 6 equally likely outcomes. If it is the equally likely outcome, then the probability of occurrence for each, probability of occurrence of each die, each outcome will be 1 by n. If we have n equally likely outcomes. For example, here comes an example. Rolling a die will have 6 equally likely outcomes. 1, 2, 3 up to 6. So the probability is 1 by n. Probability of each possible outcome is 1 by n. Totally we have 6. So 1 by 6. Okay. Here comes another example. Tossing a coin. Tossing a coin, we have total 2 equally likely outcome. Head or tail. So the probability is 1 by n, which is equal to 1 by 2. Okay. Hope you clear. Hope you are clear. Shall we move on, guys? Fine. In a pair of dice, what is the probability the score will be greater than 6 and less than 10? In rolling a pair of dice, what is the probability that score will be greater than 6 and less than 10? You just try it by yourself. Score is nothing but values on die 1 and plus values on die 2. Jayesh, Shreya, Gautam, check your calculation. Okay, let me explain this. Ranges of values for score. Ranges of values while rolling a pair of die, minimum score will be 2. It results when 2 dice takes 1 plus 1 and maximum score will be 12. Okay, 6 plus 6. So, how many outcomes are favorable for each score? I mean, 2, 3, 4, up to 12. Okay. Then you have to find the pattern for the scores. Arani, Sanyal, correct answer. Shreya, Shriram, you too. Your answer is correct. Vinod, your answer is correct. Okay, yeah. Here comes the pattern for all the scores. Starts from 3 and ends at 12. 1, 1 comma 1, 1 comma 2, 2 comma 1. So, but we want the range from between 6 and 10. So, we need to consider the scores 7, 8, 9. We have outcomes are number of outcomes 6, 5, 4. Corresponding number of outcomes 6, 5, 4. Is it clear, guys, about this pattern? Guys, shall I move on? Is it clear? Oh, Yuvraj, we need to find the probability. You have given the favorable outcome alone. Aishwarya, check your calculation. Shall we move on, guys? Is this clear? That's great. Yeah. Score of 7, 6 favorable outcome. Score of 8, 5 favorable outcome. Score of 9, 4 favorable outcome. 7, 6, 8, 5, 9, 4. Okay. So total favorable outcome is equal to 6 plus 5 plus 4, which is equal to 15. Total outcomes is 36, that we know. So probability 6 less than score less than 10 is equal to 15 by 36, which is equal to 5 by 12. Fine, guys. Good work, Yuvraj, Karthikeyan, and those who have given correct answer. Okay, shall we move on to the next question? Guys, we are running short of time. Do reply. Shall we move on to the next question? Guys? Yeah, that's great. The next method is relative frequency approach. Relative frequency of occurrence of an event is an infinitely large number of trials. Okay, for infinitely large number of trial, we can consider this one. We can do this approach, or simply number of times the favorable outcomes occurs. When the experiment is conducted for infinite large number of times. Okay, it's simply number of times the favorable outcome occurs to the experiment conduct infinitely large number of times. Okay, let's see an example. Okay, time period, number of male birth, total number of birth, relative frequency of male birth. So if you want to find the probability of male child birth, it's nothing but M by T, number of male birth by total number of births. Here comes the probability. It's for infinite number of terms. It's also same as the basic formula, probability, favorable outcomes by total number of outcomes. Here comes one more example for you. Here the value, random variable is continuous. less than 4000 to greater than 1400. It's keep on moving. It's an infinite event. Just dividing. We have to use the simple probability formula for this question also. Just try this question, guys. The same probability formula for this type also. Here given the type manufacture company maintain a record distance covered before a tire needed to be replaced. Okay, distances less than 4000, 20, 4000 to 9000, 2210, 9001 to 14325, and greater than 14,000, 445. If you buy a tire from this company, what is the probability that it will need to be replaced before it has covered 4,000 kilometer? Before 4,000 kilometers. So less than 4,000. Okay, the data was 20. And you have to find the total outcomes just by adding these things. Yes, Shreya, Arni, Aditi, Gautam, Pratosh, Vinod, Karthikeyan, Yuvraj, yeah, has given correct answer. It's very simple. By using the formula for basic probability, you'll get this. Replacement before 4,000 kilometers is equal to number of tires replaced before 4,000 kilometers by total number of tires experimented, which is equal to 20 by 1000, which is equal to 0.02. Okay. Is it clear? That's great. Fine. Let's try this. If you buy a tire from this company, what is the probability that it will last more than 9,000 kilometer? More than 9,000 kilometer. So 19,001 to 14,000 and greater than 14,000. You should include both the things by total outcomes. Yeah, most of you have given correct answer. That's great. Swati, calculation mistake. Aditi, you do. Okay, fine. Let's see the explanation. Total number of tires that were replaced after 9,000 is equal to 325 plus 445 by 1000, 770 by 1000, 0.77. Okay. Great, guys. Now try this one. It will be need to be replaced after it has covered somewhere between 4,000 kilometer and 14,000 kilometer. 4,000 and 14,000. Between 4,000 and 14,000. It doesn't include all the things. It is not included greater than 14,000. Between 4,000 and 14,000. So we should not include. We should consider greater than 4,000 and less than 14,000. Yeah, most of you have given the correct answer. Swati, Shreya. Yeah, that's great. Okay. Is it clear, guys? Shall we move on to the next concept? Shall we move on to the next concept? Yeah, that's great. Laws of probability. Laws of complements, additive law, multiplication law. Let's see these things. If A is an event, then the complement of A represents the event composed of all basic outcomes in S that do not belong to A. Complement of A is denoted as A bar. Here A bar is the light green region. A is the dark green region and A bar is the light green region. It includes all the basic outcomes in S except A. Okay? Is it clear? That's fine. Law of complement. It's nothing but P of A bar is equal to 1 minus P of A. That is probability of A complement is equal to 1 minus probability of A. Here comes an example. If the probability of a computer component being in working condition is 0.7, what is the probability that a component is defective? Working condition is 0.7. So defective will be, use the complement rule, complement law, 1 minus 0.7 is 0.3. That's great. Okay, fine. Yes. Yeah, here comes the explanation for that. So A be a event that given component in working condition. A bar will be the event that the component will be a defective. So P of A is equal to 0.7, P of A bar equal to 1 minus P of A, which is equal to 0.3. Fine. Okay, union of two events. If A and B are events, then union of A and B denoted by A union B represent the event composed all the basic outcome in A or B. It includes all the basic outcomes in A, either A or B. Here A union B includes all the region, green and yellow. Green, yellow, this common region includes everything, union of A and B. Okay, A union B. Similar way, the intersection region has given A and B are events, then the intersection of A and B denoted by A intersection B represent the event composed of all basics outcomes in A and B. A and B, this region, this red region, sorry, brown region, A and B, this alone. Fine. So let's see about additive law. A and B be two events in a sample space S. The probability of the union A and B is P of A union B, which is equal to P of A plus P of B minus P of A intersection B. Additive law is nothing but P of A union B, which is equal to P of A plus P of B minus P of A intersection B. Okay? Is it clear, guys? Note down this formula. Shall we move on? Yes. Yeah, mutually exclusive events. Events that have no basic outcomes in common, or equivalently their intersection is the empty set. That have events that have no basic outcomes in common, or equivalently their intersection is the empty set, then that event is called mutually exclusive events. Let A and B be two events in a sample space S. The probability of the union of two mutually exclusive event A and B is given by P of A union B, which is equal to P of A and P of B. If the events A and B are mutually exclusive, then P of A union B is equal to P of A plus P of B. But in general, P of A union B is equal to P of A plus B of B minus P of A intersection B. If the events A and B are mutually exclusive, then P of A union B is equal to P of A plus P of B. Since we don't have any common outcomes, A intersection B will be 0. When P of A intersection B will be 0 for mutually exclusive events. General case, P of A union B is equal to P of A plus P of B minus P of A intersection B. Is it clear, guys? Shall we try some questions? Do reply, guys. Fine. Yeah. Which of the following are mutually exclusive events? Picking a card from red suit or an ace. Picking a card from red suit or from spade. Which one is mutually exclusive? First one or second one? Aditi, correct. Gautam, you too. Rina, Gautam, good work. Shreya, correct. Okay, second one is mutually exclusive event. Red suit or spade. Okay, let's see about this. Why it is mutually exclusive? The second one. First one, event of picking ace or event of picking red card, red suit. Second one, event of picking ace. Sorry, event of picking spade or event of picking red cards, red suit. So that is the overlap between E1 and E2. So they are not mutually exclusive events. But there is no overlap between E1 and E3. Sorry, these two events is, this is E1, so this one is E3. So hence they are mutually exclusive events. Is it clear, guys? Guys, reply. Waiting for your reply. Yes, here the events are picking a card from red suit or an ace. Second is red suit or from spade. Red suit is E1, ace E2, red suit again E1, spade. This shape is spade, E3. These two are, it overlaps, no? There is an overlap. These two cards, these two red cards overlaps. So they are not mutually exclusive, but there is no overlap between these two events. So they are mutually exclusive. P of E1 intersection E3 is equal to 0. P of E1 union E2, sorry, E3 is equal to P of E1 plus P of E3. Is it clear? Shall we move on? Guys, we need to practice some more question. Do reply. That's great. Okay, what is the probability of picking one card from red suit or an ace? What is the probability of picking one card from red suit or from spade? First, give me the first solution. Shreya, check your calculation. Red suit or ace? Red suit or spade? Now, Shreya, first one is correct. Okay. Correct. Vinod, Aishwarya, correct answers. Yes, Jayesh, correct answer. Rani, correct. Aishwarya, is it audible now? Aditi, check your calculation. Am I audible now? Remy, correct. Prachita, check your calculation, please. Guys, shall I explain you this question? Do reply. That's fine. Yes. Probability of picking one card from red suit E1, which is equal to 26 by 52. One card from red suit. 13 heart red suits are there and 13 diamond red suits. Totally we have 26 red suits. From that we have to pick one. So 26 by total number of cards 52, which is equal to 1 by 2. Picking one red card picking one card of ace E2. We have 4 ace card. For each shape we have one ace card. So totally we have 4 ace card, 4 by 52, which is equal to 1 by 13. Third one, probability of picking one card of spade E3. Spade, total number of cards of shape spade is 13, which is equal to, so the corresponding probability will be 13 by 52, which is equal to 1 by 4. But we have some overlaps here. So probability of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. Okay. P of E1 intersection E2 equal to 2 by 52. Since there are two cards in common for E1 and E2, ace heartin and ace diamond. So we need to subtract it. 1 by 2 plus 1 by 13 is equal to 2 by 52, which is equal to 28 by 52. Is it clear? Yes. Second even, probability of picking one card from red suit and or from spade. They are mutually exclusive event. So probability of E1 and E2 is equal to 0. P of E1 union P of E1 intersection E3 is equal to 0, and P of E1 union E3 is equal to probability of E1 plus probability of E3. E1 is nothing but 1 by 2 and E3 is 1 by 4. So 3 by 4. Is it clear, guys? Do you have any doubts? Shall we move on to the next question? That's great. Now try this one. In an university, it is mandatory for all first year students to take a course in chemistry and maths. At the end of the semester, 15% fail in chemistry, 20% fail in maths, and 5% fail in both. Suppose a first year student is selected at random. What is the probability that student selected failed at chemistry or maths? Shreya, correct. Rani, correct. Arani. Okay. Tato, Shresh, correct. Yeah, it's very simple. Okay, let me check this. A is the event that student fails in chemistry and B is the event that student fails in maths. So P of A is equal to 15 by 100 and P of B is equal to 12 by 100, which is equal to 0.12 and 0.15. P of A intersection B means student failed in both 5 by 100, 0.05. P of A union B is equal to P of A plus P of B minus P of A intersection B, which is equal to 0.22. Guys, is it clear? Okay, that's great. Let's move on to the multiplication rule. P of A and B be independent event, then P of A intersection B is equal to P of A into P of B. Okay? P of A and B to be two independent events, then P of A intersection B is equal to P of A into P of B. Let's tell me about independent events. I'll give you an example. Pick two cards from a deck. Event 1, picking first card, and event 2, picking second card. Or E1 and E2 are independent events. Here we have two cases. If the first card is replaced, then it is an independent event. Yeah. Yes, one is independent and second is not independent. That's fine. If it is not replaced, then that is not independent. Okay, that's great. Example of independent events. With replacement, without replacement. Number of cards, 52 cards. If the first card is replaced, then E2 is independent of E1. Since the whole deck of cards is back for E2. If the first card is not replaced, E2 is depend on the outcome of E1. Since we are not replacing, now the deck contains only 51 cards, which makes it is a limited for E2 and hence it will depend on E1. Is it clear? Independent and not independent. That's fine. Here comes a question. Comes a question on this rule. Flip a coin twice. What is the probability of observing two heads? We are coining a flip twice. Yeah. I mean, we are flipping a coin twice. Yes. Yeah, most of you are given correct answer. For the first, okay, let me check. Most of you are given correct answer, but some of you have given 0.5 1 by 2. Okay, let me tell you. Tossing a coin for the first time and second time are independent, even as they don't have any common outcomes. Obtaining two heads, obtaining head in first toss and obtaining head in second task. So probability of obtaining two heads is equal to probability of obtaining a head in first task, probability of obtaining head in second task. Tossing a coin is a equally likely event. So probability is 1 by 2. Getting two heads is equal to 1 by 2 into 1 by 2, which is equal to 1 by 4. Is it clear? Guys, it's an independent event. Flip a coin twice. Shall we move on, guys? Is it clear? Two computers are ordered. If the probability of obtaining a computer in working condition is 0.5, what is the probability that both of them are working condition? Yes, Rami, Aditi, Pratosh, most of you are giving correct answer. That's fine. That's fine. It's very simple, no? Yeah. Given the probability of getting a working computer is zero point 0.7, two computers are ordered. So we need to find the probability that both are working condition. Both are in working condition. So probability both are in working condition is equal to probability first computer in working condition and second computer will be working. So both of them working is equal to 0.7 into 0.7, which is equal to 0.49. Okay, shall we try some questions on this, guys? Okay, now we'll try some tougher questions based on the concept we have studied till now. Okay? That's great. Actually, from probability, you can expect two questions in your GRE. Students are finding difficult in probability permutation combination sessions only. Okay, let's start this practice questions. Here comes the question. A child is having a biased coin. He tossed the coin 50 times, out which he get 36 heads and 4 tails. Suppose the child is tossing the coin once again. Find the probability that the child is getting head. Find the probability that child is getting head. Here the coin is biased coin. It's not an unbiased. If it is unbiased coin, then the probability is 1 by 2. Okay? It's a biased coin. Here the probability will be number of possible outcomes by total number of outcomes. Yes, biased. Unbiased mean the coin contains both different sides. In one side you'll get tail and another side you'll get head. Okay. It's an biased coin. It may contain anything. So you'll have to use the general formula, number of possible outcomes by total number of outcomes. Fine, most of you have given the correct answer. Let me check. If the coin is unbiased, then probability of getting head is 1 by 2. Probability of getting tail is also 1 by 2. But here it is given that coin is biased. Okay. So child had tossed 50 times, tossed the coin 50 times, out which he got 36 heads and 14 tails. Okay. So probability of getting head is equal to number of favorable outcome by total number of outcome, which is equal to 36 by 50, which is equal to 18 by 25. Is it clear, guys? Pritam, don't worry. Soon we will upload the slides and recordings of this online seminar in our website. You can utilize it. You just try these questions. Okay, shall we move on to the next question? Shall we try some more questions? That's fine. That's fine. From a pack of 52 cards, 3 cards are picked randomly. What is the probability that 3 cards are of same suit? From a pack of 52 cards, 3 cards are picked randomly. What is the probability that 3 cards are from same suit? Krishnaveni, check your calculation. Okay. We have to select 3 cards from same suit. We have 4 different suits: spade, heart, diamond, and flower. For each suit, we have 13 cards. Out of 13, we have to select 3. Since it is a selection, we have to use combination. Out of 13 cards, we have to select 3 cards. So the combination will be, can you give me a reply? Aditi, yes, almost correct. Combination, no, I'm just, total outcomes is 52 C3. That's correct. Pritam, that was correct. Total possible outcomes is equal to 52 C3 because we need to pick 3 cards. Number of possible outcome. Prachita, you are almost correct. There are 4 different suits, so you'll have to multiply that with the selection. 4 into the selection is 13. In each suit we have 13 cards. 13 C3. Aishwarya, great, correct answer. Okay, let me explain this problem in detail. From a pack of 52 cards, 3 cards are selected randomly. Okay. Here, what should be the total number of outcomes? From the pack of 52 cards, 3 cards are selected randomly. So, the total number of outcome is 52 C3. I guess you all clear up to this. Okay. Then what is the number of favorable outcome? All the 3 cards should be selected from the same suit. It's given in the question. So we know that there are in all 4 different suits and 13 cards have the same suit. We have to select 3 cards from 13 cards of same suit. We have to select 3 cards from 13 cards of same suit. This can be done in 13 C3 ways. But we have 4 different suits. For each suit, we have 13 C3 ways. But we have 4 different suits. So, number of favorable outcomes is equal to 4 into 13 C3. Is it clear? Number of favorable outcome is equal to 4 into 13 C3. Since we have 4 different suits and for each suit, we have to select 3. Guys, is it clear? Shall we move on? Do reply. We are running short of time. So the probability required probability is equal to 4 into 13 into 2 into 14 into 12 into 13 into 12 into 11 by 52 into 53 into 51. Okay, the answer is 22 by 425. Is it clear, guys? 4 into 13C3 by 52C3. Combination formula is n factorial by n minus r factorial into r factorial. Shall we move on, guys? Do reply. Okay, now try this one. Suppose the die is rolled. What is the probability of getting an outcome as a multiple of 3? Given that outcome is an even number. Die is rolled. What is the probability of getting an outcome as a multiple of 3 given that outcome is an even number? It's a conditional probability. Problem is based on conditional probability. I'll tell you the formula for conditional probability. P of A given B is equal to P of A intersection B by P of B. Formula for the conditional probability P of A given B is equal to P of A intersection B divided by P of B. Shreya, correct. Here we need to find the probability of getting an outcome as a multiple of 3 given that outcome is an even number. So based on the formula P of A given B, if I consider that B as multiple of 3 given that if I consider the event B as outcome is an even number, so event B will have 2, 4, 6 if we roll a die. The possible outcomes are 1, 2, 3 up to 6 and outcome is an even number 2, 4, 6 and outcome is a multiple of 3. A is the outcome is a outcome as a multiple of 3 which is equal to 3, 6. Probability of A given B is equal to probability of A intersection B by P of B. P of B is equal to 2, 4, 6. I told you no. Even B is equal to 2, 4, 6. So 3 by 6. And P of A intersection B we need to find. Let me explain about this problem in detail. Okay, let us define the events. The outcome is a multiple of 3. Event A is outcome is a multiple of 3. Event B outcome is an even number. A is equal to 3, 6 and B is equal to 2, 4, 6. Is it clear, guys? Guys, any doubts? So, in order to calculate the conditional probability P of A given B, we need to find P of A, P of B and P of A intersection B because P of A given B is equal to P of A intersection B by P of B. To find P of A intersection B, we need P of A and P of B. Okay, and P of A is equal to 2 by 6 because A contains 2 elements 3, 6, 2 by 6 and B contains 3 element 2, 4, 6, 3, 6 which is equal to 1 by 2. P of A intersection B, we have an element called 6 that includes A and B. So P of A intersection B is equal to 6. Sorry, A intersection B is equal to singleton set 6 and P of A intersection B is equal to 1 by 6. So P of A given B is equal to Yathan, multiple of 3 or 3, 6, 9 but here we are rolling a die. In that we have only two possible outcomes 3 and 6. Is it clear, Yathan? Yeah, Chakrapani, right. We are rolling a die. We are rolling a die. Die is rolled. The die is rolled. Yatin, is it clear? Yeah, Debashish, here we have the condition. What is the probability getting an outcome as a multiple of 3 given that outcome is an even number? So we have another event. Outcome is an even number, and one more that event has already occurred. This outcome as a multiple of 3 is going to occur. So we have two events, outcome as a multiple of 3, given that occurred event is outcome is an even number. So given event is a P of B, event B, and outcome as a multiple of 3 is A, event A. Is it clear? Yeah, it's a formula. It's available in your learning tracker. I forgot to include that formula here. Okay, I told you the formula in the beginning also. Is it clear, guys? Yatin, any doubts? Shall we move on, guys? Okay, yes. So P of A given B is equal to P of A intersection B pi by P of B is equal to A intersection B is 1 by 6 and P of B is 1 by 2, which is equal to 1 by 3. Okay, shall we move on to the next question? Shall we try some more questions? Do reply, guys. Okay, it's very simple. Just give a guess. Probability that it will rain today is 0.7. If it is raining on a particular day, then the school will remain closed. What is the probability that the school will be closed today given that it will be rain today? Arani, correct. Probably it will rain today is 0.7. Probability that school will be closed today. Probability that school will be closed today, that it will rain today. Chakramani, Gautam, check your calculation. Kartikeyan, Shraddha, Debashish, correct. Actually, it's an sure event. Okay. Probability of sure event is 1. Probability that it will rain today is 0.7. If it is raining on a particular day, then the school will remain closed. Okay. We need to find the probability that school will be closed. We need the probability that school will be closed. We don't want the probability it will rain. But so the probability is 1. Is it clear? Even if you use conditional probability, you will get the same answer 1. Probability that it will rain today is 0.7. It's given in the question. If it is rain on a particular day, then the school will remain closed. What is the probability that the school will remain closed? Given that it will rain today. The probability that it will rain today will not affect the probability that school will be closed today. Because if it is rain, then school will be closed. Here it's rain, so here it's given that it will rain today, so the school will be closed. It's an sure event. It will happen because it's given that it will rain today. So the event will definitely happen. Probability of that event is 1. Sure event is 1. Is it clear? That's fine. Okay, now try this one. In the class of 15 boys and 10 girls, the class teacher want to select one class representative and one cultural representative. What is the probability that the class representative is a boy and the cultural representative is girl? Pritam, give me your final solution. We need to find the probability. 15 boys, 10 girls. We have to select one class representative, one cultural representative. What is the probability that a class representative is a boy and the cultural representative is girl? Okay, let me explain this question. Can you just tell me? There are 15 boys and 10 girls. The total number of outcomes? Is it 25C2 or 25P2? It should be 25P2. Right? Guys, it should be 25P2. Right? Because we have to select two of them and we should designate them. So 25P2. Okay? We have two different positions, class representative and cultural representative. We have to select them and we have to designate them. Selection is process of selection alone is combination. Process of selection and arrangement is permutation. Clear? It is 25P2. Any doubts, guys? So can you give me the final answer? Class representative should be a boy. Hence the class representative can be selected in 15 ways. Similarly, cultural representative can be selected in 10 ways. Hence the number of favorable outcomes will be 15 into 10, which is equal to 150. Yes, most of you have given correct answer now. So required probability is 150 by 25 into 24, which is equal to 1 by 4. Guys, is it clear? Here we need to use permutation because we have to select two students and then we have to designate them. Class representative and cultural representative. So we need to use permutation. Is it clear? Shall we move on? Answer is 1 by 4. Chakrabani? Shall we move on, guys? Okay. Just try this question. Suppose there is a pack of 52 playing cards. A man picks the card first and then a woman picks one card from the same pack. What is the probability that the woman picks the ace card? Suppose there is a pack of 52 cards. A man picks first card and then a woman picks one card from the same card. So we'll get two different cases here. What is the probability that the woman picks the ace card? Prachita, kindly check your side, internet side speed. Yeah, I'm not getting error from anyone else. Okay. Shall I explain you this question, guys? We have two different cases. Consider a event A. Man select a ace card and A dash man doesn't select the ace card. If man select the ace card, then the probability will be 4 by 13. Probability of man selecting ace card. Man doesn't select ace card. Rest of the things. Okay, let me explain in detail, guys. It is given that man picks the first card and then woman picks the one card from the same pack. A be the event, man select an ace card. B be the event, woman select an ace card. Will the occurrence of event A will affect event B? Any idea, guys? Will it affect? Yes. Yeah. If he picks, then woman will have only 51 cards. Sorry. Woman will have only 3 ace cards, not 51 cards. Anyways, he will have, woman will have 51 cards. Out of that, she'll get only 3 ace cards. P of A is equal to 4 by 52. Getting ace cards. Getting a card except from ace is 52 minus 4, which is equal to 48 by 52, which is equal to 12 by 13. So if event A occurs, then event B. Woman will have only 3 ace card out of 51 cards. So P of B is equal to 3 by 51. If event A doesn't occur, then P of B will be 4. She can choose any one from 4 ace card. So 4 by 51. So the required probability will be, probability that the woman picks the card, ace card, will be 1 by 13 into 3 by 51 or 12 by 13 into 4 by 51, which is equal to 1 by 13. Some of you have given correct answer. Congrats to them. Okay, is it clear? Any doubts, guys? Gautam, any doubts? P of A dash, if man doesn't pick ace card, 48 by 52, which is equal to 12 by 13. We have used that one here. Doesn't pick ace card and woman picks the ace card, 4 by 51. Man picks the ace card, 4 by 52, and woman picks the ace card from the same pack, 3 by 51. Guys, is it clear? Either this case will occur or this case will occur. Okay, guys, we are running short of time. We'll wind up the web seminar, online seminar. From this, okay, just try, give a try. If you roll a die, then the probability of getting even number is 1 by 2. What will be the odds in favor of even number and odds against even number? Odds in favor is equal to favorable outcome by number of non-favorable outcome. Odd against is number of non-favorable outcome by number of favorable outcome. That's the formula. Prachita, Remy, correct. Here the probability of getting even number is 1 by 2. What will be the odds in favor of even number and odd against? Odds in favor is equal to favorable by number of non-favorable. Here comes the formula. Odd against non-favorable by number of favorable. It's coming under, it's a separate concept coming under probability. In your learning tracker, you'll get this. Favorable outcome by non-favorable outcome. Here the event is even number, favor of even number. even numbers. When you throw a die, you'll get the even number 2, 4, 6. So non-favorables are 1, 3, 5. Number of favorables by number of non-favorables. You just give me your solutions, guys. Okay, let me explain. Number of favorable outcomes by non-favorable. Number of favorable even. That's nothing but 2, 4, 6. Now counts will be 3. Non-favorable 1, 3, 5. Counts will be 3. 3 by 3 is equal to 1. Similar way, non-favorable by favorable 3 by 3 is equal to 1. Is it clear, guys? Do you have any doubts? That's fine, guys. Thanks for attending this webinar, online seminar. I'm sure it's useful for you. If you have any general queries, you please post it now. I'll answer your query. Thank you so much. And all the very best for your preparation and all the very best for your GRE.